Topic 1-2, solving multi-step inequalities, referenced in our Holt textbook, Chapter 3, Section 4, on page 188. I put a number line down here because a lot of what we're going to be looking at in these multi-step inequalities is knowing our integer rules, not just adding and subtracting integers, but also multiplying and dividing. Also remembering what happens when you multiply or divide by a negative. You've got to remember that your sign, your inequality sign, is going to change. Let's look at this first example. You've got 12 plus 3a is greater than 18. If you'll remember that it's isolating the variable, is what we're wanting to do. So eventually we'll do something with that 3. That's the coefficient in front of the a, but a is what we want to isolate. So if you subtract 12 on both sides, that goes to 0. If you have 18 and you subtract 12, you're left with 6. Bring down the 3a, greater than or equal to 6. They don't show that step, but right here, you're dividing by 3. Therefore, the a's go away, so a is greater than 2. Again, it's an open circle. Showing greater than would go this direction. If you want to you're going to create your number line, your number lines. You can actually put the open circle on the actual number line and darken with a dark arrow. That would work too. Okay, let's look at number 2. Let's just try to keep everything else covered up. All right, let's look at this one. You've got one variable on both sides. You also have a constant on both sides. Where you start doesn't really matter. You just pick something to move. You're going to balance the equation across the inequality. So if you want to draw your line, you can, but you're looking to balance it so whatever you do on one side, you also do on the other side. If you subtract a 5r, that goes away, leaving you only with the 3. If you subtract 5r from 2r, it's negative 3. In integer rules, and I'm going to just take a minute and look at that. If I'm at a positive 2 and I subtract 5, 1, 2, 3, 4, 5, you're moving in this direction 5 units in the negative. So you're taking away 5 units. You would end up at a negative 3. When the signs are opposite, positive 2, negative 5, you ignore the sign, subtract, and then take whatever sign that's the larger number. But visualizing it with a number line also can help. Okay, so if r is what we're trying to get rid of, trying to isolate, then we need to move the 18 to the other side, not the 3 to this side. So by adding 18, they go away. 18 and 3 is 21. This is where we're actually dividing by a negative 3. Division of a negative 3 leaves you with a negative 7, but you've got to remember that the sign flips. You have to flip the sign. So now it's r is greater than or equal to, represented by a solid circle at 7, and everything greater than 7. So looking at a number line, here is your 0. Everything in this direction are the positive numbers, with this direction being negative numbers. So as you move to the right, you have positive. If you're moving back to the left, it's negative. So it's getting smaller. The values of a negative 9 is actually greater than a value of a negative 10, negative 11, and so on. As the negative numbers get larger in number, their value is actually smaller. So if it helps, I've got some blank number lines if doing these problems with actual visual number line, then ask your teacher for one. Okay, let's look at another example. This one's quite long, But again, if you keep your inequality in the same direction, parentheses need to be distributed. I'll show this with arrows. If you'll go slowly, you can get these answers correctly. But there's 3 parentheses, therefore I'm going to have to distribute 3 times. 5 times k is 5k. 5 times 4 is 20. Negative 2 times k is negative 2k. Negative 2 times a positive 6, this is our integer rules of knowing negatives and positive, form a negative 12. There's my inequality sign. 5k, multiplication, and so on. 5 minus 1. Then you're looking at some k's all on the same side of your inequality sign. These have to be combined. So 5 minus 2k is 3k, and a positive 20 and a negative 12 is a sum of 8. Here, the only thing that needs to be combined is this positive 5 and this negative 1 to become a positive 4. So now we have an equation that looks similar to example 2 in that you want on the same side of your equation your k's and then your constants on the other side. So they've chosen to move, they didn't show the step, but they chose to move the negative 5. So make sure you bring the variable with it. A lot of times my students will just put minus 5 and not bring the variable, and then they end up subtracting the 5 from the 8 possibly and not the k. Keeping like terms together. Always keep like terms together. So again, you're looking at a positive 3 and a negative 5. On a number line, I'm at 3. Let's show it on this. I guess I can show it on this one. Move this up a little bit. You are thinking to yourself that you're at a positive 3, and in the action of movement negative 5 is this action here. 1, 2, 3, 4, 5, leaving me at a negative 2, so I'm at the negative 2k. Those 5s went away. This 8's still there, and so bring down your 4. It's best to line up your inequalities. This one's not lined up too well, but it's okay. Again, the next step would be to, you want the k by itself and the constants together, and here's your inequality sign. You're not subtracting 4 from both sides, you're subtracting an 8 from both sides. That would go away, leaving you a negative 2k. Again, you're at a positive 4. Again, shown on a number line. I'm at a positive 4, and I'm going to go down a negative 8. I'm going to end up all the way over here. Subtracting 8 units would leave me at negative 4. So again, subtraction when they're opposite signs, and take the sign of whatever the larger number is, will always be the right rule to use. Then again, remember you've divided by a negative 2 on both sides. Again, they're not showing the steps that I've added in here, so if you need to show every single step, then do so. Because when 2 negatives are divided, they become positive. 2 negatives divided or multiplied will always be a product of a positive. Okay, several more examples before we move on. Let's look at this one. Bring it down. Okay, look at number 4. You had to distribute 7a minus 7. That's just using the distribution of the parentheses. Combine like terms got me to the negative 4. Brought down the 7a. This continues to be brought down. But look what happens here. When you subtract 7a on both sides, guess what happens? Your whole variable goes away. So now you're looking at either whether it's a true statement or a false statement, in that is 0 less than a negative 4. Well, looking at our number line again, trying to find one I have it written on. Oh well, it's okay if this one's written on. You look at negative 4, here's where your negative 4 is, and here's where 0 is. Well, 0 is greater than a negative 4, not less than a negative 4. Therefore, the way you would answer this problem is that there's no solution. You can show it like that, and then you wouldn't be able to graph anything. So if you were asked to graph it, you wouldn't put it. You would just leave the graph blank. Okay, last one on this one. Distribute both sides. Carry everything down. This one again, if you add a positive 5x to both sides, both your variables on both sides go away so that you're left with just the 15 and just a positive 1. This statement, however, is true. If I have a positive 1, is it greater than, way down here would be my negative 5? Yes. Or read it the other way. Negative 15 is less than 1 would also be true. So if this is the case and the x's go completely away, your answer is all real numbers. So you would actually just draw a line maybe with a 0 and show it going in both directions. That includes all real numbers. So take a minute, pause it, try number 6 on your own, and then check your answer. And that concludes 1-2.